You're setting up a scraper, following the docs, and you keep seeing this. Or maybe you're configuring a tool, the drop-down asks you to pick HTTP or SOCKS5, and you're not sure which one you want. Hey, I'm Aleksas, R&D engineer at Oxylabs. In this video, I will explain what SOCKS5 actually is, how it stacks up against HTTP proxies and the older SOCKS4, and when you'd reach for it. By the end, you'll know which one fits what you're doing and why. Let's set the stage first. A proxy sits between your device and the website you're trying to reach. Everything you send goes through it, and everything comes out back through it. But here's what most people miss. Not every proxy handles the traffic the same way. The protocol is just the set of rules for how the proxy deals with your traffic. Whether it reads it, changes it, or simply passes it along untouched. And that difference matters more than you think, once you go beyond basic web requests. So what is SOCKS5? It's a protocol, one of those sets of rules we just talked about. It sits just beneath the apps you're using, and it doesn't care what kind of traffic you hand it. Whatever you're sending, SOCKS5 just passes it along without ever opening it up or changing it. Think of it as a courier that doesn't open your package, doesn't read what's inside, and doesn't decide whether to deliver it. It just gets it where it's going. The name itself comes from sockets, the connection points that let programs talk to each other over a network. It opens a connection through the proxy on your behalf and sends everything down that line. So the website on the other end only ever sees the proxy's IP address, never yours. Now, you might run into SOCKS4 in older docs. It's the previous version, and the differences are worth knowing if you're dealing with anything legacy. SOCKS4 is pretty limited. It can handle UDP traffic, there's no way to log in with your username and password, and it doesn't support newer style IP addresses or private address lookups. SOCKS5 fixed all of this. You can lock it down with a username and password. It handles real-time traffic, not just the regular kind. It works with a newer IP address format, and it can take care of looking up the site's real address for you on the proxy side, so that the step doesn't happen on your machine where it could give away which sites you're visiting. This is the comparison people ask about most. SOCKS5 versus HTTP proxy. Both send your traffic through a middleman, but they go about it in completely different ways. An HTTP proxy actually understands web traffic. It can read your requests, look at the headers, store copies of pages, and filter what passes through. That's handy in some situations, but it means the proxy is getting involved in your traffic. And it only works for regular web requests, nothing else. SOCKS5 does none of that. It sits below all of it. It doesn't try to understand what you're sending. It just opens a connection and passes your data straight through. That's the whole idea. So it's not that one is better than the other. It's which one suits the job. An HTTP proxy is great when you specifically want that web-aware behavior, caching, filtering, that kind of thing. SOCKS5 is the one you want for anything that goes beyond regular web traffic, or anything you just need a clean, no questions asked connection. So where does SOCKS5 actually turn up day to day? Let me run through the big ones. Web scraping is number one. When you're gathering public data from sites at scale, SOCKS5 lets you spread your requests across lots of different IPs with very little overhead. And most of the common tools support it out of the box. Next, anything that mixes different kinds of traffic. If you're using tools for file transfer, email, or real-time stuff like voice calls, gaming, or streaming, SOCKS5 takes all of it in stride. An HTTP proxy simply can't. Then there's privacy-focused work. Because SOCKS5 never reads your traffic, and because those address lookups happen on its end, it's a popular pick for security research and private browsing. Anywhere you don't want a single layer of your setup peeking at what you're doing. And more you'll see it in automated setups, test environments, headless browsers, and rotating proxy systems where developers want that low-level control. Now, here's something worth clearing up, because a lot of stuff online gets it wrong. SOCKS5 is not encryption. Saying SOCKS5 is more secure is at best only half the story. SOCKS5 doesn't scramble your traffic, it just carries it. Whether your data is protected depends entirely on what you're running on top of it. If you're loading a secure site through SOCKS5, It's that secure connection doing the protecting, not SOCKS5. SOCKS5 is only the delivery. What SOCKS5 gives you is a privacy of a different kind. The site never sees your real IP, and the proxy passes your traffic along without inspecting or changing it. It's just not the same thing as encryption. One more thing that comes up a lot: the difference between the two main types of traffic. Most of what you're dealing with is the careful kind. It sets up a proper connection, makes sure everything arrives, and resends anything that gets dropped. The other kind is faster but looser. It fires data off without checking it all lands. You give up some reliability for speed, and it's what's behind things like voice calls, video streaming, and online games. The old SOCKS4 could only handle the careful kind. SOCKS5 added support for the faster kind too, which is exactly why it's the right call anytime you're working with real-time stuff that can't wait around. Okay, let's look at how you actually set one up. In most cases it's pretty quick. In the terminal, you point your command at the proxy and tell it to use SOCKS5. If you need to log in, your username and password go right in there too. In Python, there's a small add-on called PySocks that handles it. You just tell your code to send everything through the SOCKS5 proxy. And in a browser like Firefox, you can plug the proxy's address and port straight into the network settings and flip one switch so your address lookup goes through the proxy as well. That hands-on setup is perfect for testing things out, but once you need thousands of IPs, automatic rotation, and something that just keeps working, that's where a managed service comes in. You let the provider deal with all the messy parts, and your code just talks to one address. That's exactly what we do at Oxylabs. If you'd like to try our SOCKS5 proxies, there's a link in the description. We have got a residential data center and ISP, all with worldwide coverage, all supporting SOCKS5. And if you want to go further, everything's there for you. Full set of docs at developers.oxylabs.io and a team of live chat or at support@oxylabs.io whenever you need a hand. Thanks for watching. If this helped, the video on residential proxies is a great next step. See you there.